Okay, good morning, everybody. So the topic of today's lecture is interfaces. So we're still talking about the relationship between classes. So we're still trying to build classes that have fields that are references to other objects. The next relationship we want to talk about is something called inheritance. But before we get there, we're going to talk about a related concept, and that is interfaces and how do you create and implement an interface. So the two interfaces are related to inheritance. Okay, so remember what an interface is. So we've implemented the compare-to interface already in the course. Right? So remember the comparable interface lets you compare objects of your type for order. Right? So they let you sort objects of your type. So remember that when we implemented the interface, there was a method in the interface called compare-to that we had to provide in our class. Right? And so that's all that an interface is. Right? An interface is simply a specification of the methods that an implementing class must provide. Right? So an interface simply says any class that chooses to implement this interface must provide these methods, and this is what these methods are supposed to do. Exactly how those methods are implemented is up to the class. Let's see. Okay, so interfaces define a type. And so you can actually create a variable whose type is an interface. So there's an array list object on the right-hand side of our assignment. Right? But on the left-hand side, we've got a variable t, and its type is list string. Right? It's not array list string, it's list string. Remember, a list is an interface. Right? And so interfaces are, in fact, reference types in Java. Right? What you can't do is you cannot make a new list. Right? So you can't make an instance of an interface. Right? You can create a variable whose type is an interface, but you can't make an object that is a list. Right? You have to make an object that is a class that implements the interface. Right? And so new list doesn't make sense in Java. Right? New set doesn't make sense in Java. New map doesn't make sense in Java. Right? But new linked list, well, that makes sense. Right? Furthermore, linked list is a kind of list. So a linked list is a class that implements the list interface. So I can store a reference to a linked list object in the variable t. Right? And if you make your own list class for some reason, called myList, right? As long as you create your class, and when you create your class you say it implements the list interface, you can now store a myList object in your variable t as well. Right? And anybody who makes a class that implements the list interface, you can store an object of that type in the variable t. Okay, so a class that wants to implement an interface simply provides all the methods in the interface. Right? So implementing comparable, you simply provide compare-to. The iterator interface is an interface that you've been using even though you probably didn't know it. Right? So an iterator is an object that knows how to iterate over a collection of elements or a sequence of values. Right? And so when you iterate over a collection or a sequence, you would normally you'd write a for loop. Right? And if you're using a counting style loop, for int I equals 0, I is less than something, blah, 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 blah. Right? When you use a for each loop, what's actually happening is that the language is creating an iterator for you, and that's the iterator object that knows how to iterate over your sequence or collection. If you want to iterate over a sequence, if you want to iterate over a list or set and remove elements from the list or set as you're iterating over the collection, the only safe way that you can do it is to use an iterator object. I haven't shown you how to do this, and I haven't asked you any questions on any of the assignments for doing this. But if you're interested in the details and you're looking at the notebooks, you can actually go and look in the list and set notebooks and see exactly how you go about doing this. Whenever you write a for each loop, right? So for each string s in the list t, the language is making an iterator object for you. Right? So actually I have an example here for you. Okay, so in today's lecture, I'm going to make a class called range. Range is just like interval that you implemented on assignment 4, right? 4 or 3? 3, assignment 3, right? So it's just like interval on assignment 3. It represents an interval or a range of values. So here I want to iterate over a range. So I want to iterate over the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And this is just like you would write, this is almost exactly what you would write in Python. Right? In Python, if you want a counting style loop, you write a for each loop that iterates over a range object. So in Java, when you write that, right, that's a for each loop. Right? What actually happens is the following. Right? And so we're going to make a range object here. Right? That corresponds to that range object there. Right? So they are, in this case, they are identical ranges. Right? And Java, the compiler translates that loop, that for each loop, which is nice and easy to write, into a somewhat more complicated loop, which takes a lot more effort to write. Right? And so what happens is when you have this range, Java makes an iterator over the range. Right? The only reason it's able to do this is because your range class here, or the sequence that you're iterating over, it promises to provide an iterator method. Right? So in other words, it implements an interface where one of the methods is called iterator. And iterator returns an object that knows how to iterate over the sequence. Right? Every iterator has a method called hasNext. So hasNext returns true if there are still more items in the sequence to look at, right? And it returns false when you've looked at all the items in the sequence. Right? So this simply says make an iterator that starts at the beginning of the range, so it starts at 0. Right? As long as we're not at the end of the range, so in other words, as long as we're not at 10, do something. Right? Notice here the update statement is missing. It's going to be inside the loop instead. So inside the loop, we call the method next on the iterator. Right? So the method next gives you the next item in the sequence. Right? Or I guess the current item in the sequence. Right? So that iterator there starts at 0. Right? First time through the loop, next returns 0, right? And then it advances the iterator to the next item in the sequence. Right? So we print out the value of I. Next time through the loop, we check this condition. Right? So remember, our iterator is now at 1. Right? So hasNext returns true because our iterator is not at 10 yet. Into the loop we go. ItterNext returns 1, right? The current value that the iterator is looking at. Right? And then advances the iterator to the next position. Right? Print out I, and so on, and so on, and so on. Eventually, we get to 9. Right? So when we get to 9, ItterNext returns 9. Right? Advances the iterator to 10. Print out the value 9. Next time through the loop, right? hasNext gets called. Right? The iterator is now at 10, which is at the end of the sequence. So hasNext returns false, and now the loop stops. Right? So I think hopefully you all agree that's much easier to write than this. Right? And so when you're writing this, right, the compiler is actually translating your code into this. Right? The only reason it can do that translation is because our range class implements this interface called iterable. Right? And iterable is the interface that says the class must have an iterator method. Right? There's actually a second interface at play here. Right? The other interface at play here is the interface called iterator. Right? That's not so the iterator type is not an object, is not a class type. It's actually a interface type. And so the second interface at play here is the iterator interface. The iterator interface says every iterator object has a hasNext method and a next method. Right? Again, this is the only reason why the compiler can translate that code into that code. Right? It knows a range has an iterator method, so it can call iterator on R. Right? And it knows every iterator has a hasNext and a next method. So using iter, it can call hasNext and next. Yes, question?
I had a question about that photo.
Sure. The second one?
Yeah, so when on Java, we used to sing the for each loop or the other type of loop that we've seen earlier in the class, we have like an initialization and a condition and some kind of like increment or decrement.
That's right.
Over here, you only have 2 statements.
That's right.
So
Yep.
So why doesn't Java raise the syntax errors?
There is no syntax. So in a counting style loop, all 3 of these things are optional. So that is optional, right? That is optional, and that is optional. That's how it works in Java and the C-like. All the C-like languages work like that, right? When you write a counting style loop like this, all 3 parts are optional. They have to be, typically to make the loop work properly, they have to be somewhere, right? So that thing there is actually Normally you would, in a standard style counting loop, you would put that up here. But we don't want to put it up there because we actually need the value returned by next inside the loop. Right? And we want to call next not at the end of the loop, right, but before we print it out. Right? So remember, whatever is here gets called at the very end of the loop. Right? So structurally, it doesn't work if we put the iter next statement there. Yes?
What is the difference between an interface type and a class type?
They are both reference types, right? So they are both, so number one, they're both types, right? They're both reference types in Java, right? Classes can be used to create objects, right? That's the main purpose of a class, right? A class defines a user-defined type that is typically used to create objects, right? An interface is never used to make an object, right? An interface is a type that simply says any class that implements this interface must provide these methods. Right? Does that answer your question? Okay. Any other questions? All right. So an iterator is an object that knows how to iterate over a collection or sequence of values. I just showed you that when you write a for each loop, Java actually translates your code so that it uses an iterator. It actually uses an iterator object to iterate over the sequence or collection that you are iterating over. Right? And so the language hides all of this complexity from you. But again, the only reason it can do this is because the interfaces iterable and iterator say that these certain methods, say that particular methods exist. Right? And so when the compiler does the translation, it can safely call those methods. Right? So here's what the iterator interface looks like as far as we're concerned. Right? This is what it looks like. There are actually more methods in the interface. One of them we'll look at later in the course. The other one you would not normally encounter in a course of this level. Right? Okay, so there's the iterator interface. So first of all, iterator is an interface, it's not a class. Right? So again, you cannot make an iterator object, right? But you can make a class that implements this interface. Right? This thing T, so this is the type of element that you are iterating over. So if you have a list of strings, right, your list class, or sorry, if you have an array list of strings, right, the array list class produces an iterator where this thing is string, right? It iterates over a sequence of strings. Right? If you have in our range example, right, we're iterating over a sequence of integers, so our range class is going to produce an iterator where T is number, right? So that's the element type that you're iterating over. I think I've described what has next and next do, right? But just to remind you, has next returns true if the iterator has more objects to look at in the sequence, right? And it returns false otherwise. Next returns the current item or current element that the iterator is looking at. So that's the iterator interface. The iterable interface, right? So there's a second interface at play here, right? The iterable interface is the one that says the iterator method exists for this type. Right? By implementing the iterable interface, you can make your class or objects of your class a target for a for each loop. In other words, you can write a for each loop if you have an object of your type. Right? So list and sets, we know that those, you can write a for each loop over a list or set. Right? They all implement the iterable interface. Right? So if you have a list of string, it implements a iterable string interface. Right? If you have a list of double, it implements the iterable double interface. And the same is true for set. Right? If you have a set of dates, right, it would implement the iterable date interface. Right? We also know that you can write a for each loop over arrays. Right? So if you have an array, you can write a little for each loop and look at every element in the array. It turns out that in Java, they don't actually implement the iterable interface. Right? Instead, the compiler pretends that it does, and it generates the code that it needs to iterate over an array. Right? In the iterable interface, we only care about one of the methods. It's called iterator. Right? So the iterable interface simply says the class can provide an iterator, right, to iterate over its elements, where the element type is T. Okay, so in Python, you'd like to write a counting style loop. Right? Python only has one kind of for loop. Right? Python, every loop is a for each loop. Which is actually nice, right? It simplifies the language. when you work in a language like Java or C, right, there are two types of for loops. Right? So if I want a counting style loop in Java, you'd have to, typically you would write for int I equals 0, I is less than something, blah, 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 blah. Right? If you want to pretend you're a Python programmer in Java, right, you now need to create a range class that you can write an iterator, that has an iterator method. Right? So this is Python, right? In Java, the closest we can get is to do something like this, right? Write a for each loop, iterating over a range object, right? This range object counts from 0 up to but not including 10, right? Just like Python's range object here, right? Counts from 0 up to but not including 10. So this is similar to the, sorry, this is from an old lecture slide. This is similar to the interval class in assignment 3, right? It's exactly the same thing. Okay, so how does this work? So rather than look at the slides, let's try to implement this in Eclipse, knowing what we know in the course so far. So I'm going to make a class called rangeIter. Right? So rangeIter is going to be my iterator that can implement, that can iterate over a range of values. Oh, first of all, I guess I should show you the range class. Let's do that first. Okay, so here's range. There's our range class. So our range class wants to start at some value, and it wants represents a sequence of integers that start at some value. So I'm going to call it start, right? You can call it min, right? So in interval, it was min and max. Here it's start and stop, right? For the range, stop is not part of the range, right? So it's one past the end of the range, right? So how do you implement the rest of the class? Well, you probably want a constructor, right? You may want several constructors, but here I'm going to have just one. Sorry, I have two here, sorry. So here's my constructor that takes in just the stopping value, right? So this assumes you're going to start at 0. Right. There's our constructor that takes in both the start and stop value, right? Where the start value has to be less than the stop value, right? And that's it. So that's all you need for the class, right? So your range represents a sequence of integer values starting from some minimum value up to some maximum value. Right? And so that's all you need to implement range. Right? So ignore this implements iterator here for now. Right? So we're going to do this in a separate class. Oh no, sorry, let me back up there. We want to iterate over a range, so we have to implement the iterable interface. Right? Here we go. So the iterable interface says you must provide an iterator method that returns an iterator over the range of values. Right? So here I'm going to return a new rangeIter object like that. And we'll get to this in just a second. Right? So I want to return a new iterator object that can iterate over the range. Okay, so now at this point you have to ask yourself the question, so what does a rangeIter object need to know? Right? So what information does it need to know? Right? Well, it needs to know what is the minimum and maximum values of the range. Right? So remember, it's going to start at the beginning of the range, it's going to go up to but not including the end of the range. Right? So this constructor for rangeIterator needs some information. Right? It needs we need to tell the rangeIter object, right? We either need to tell it what range are you iterating over, right? Or we need to tell it what is the minimum and maximum values of the range. Right? I'm going to choose to tell it what range is the iterator iterating over. Right? So I'm going to pass to the rangeIterator constructor a reference to the range. Right? A reference to the range is simply this in this particular method. Right? That's a non-static method. Right? Remember, in a non-static method, the word this refers to the object that was used to call the method. When I call this is what I'm going to do. Right? So when I call the iterator method, oh wait, I'm doing this in a funny way. Hang on, let me fix this in a second. This is a funny way to do it. r.iterator, that's what I want to do. There we go. And I have to change my iterator implementation up here. Oh, good, okay. Right, so that's what you want to do, right? So when you call the iterator method, inside the iterator method, the keyword this refers to the object that was used to call the method. So in this case, I used R to call the method, right? And R is that range that I created on the line above. Right? So the range iterator constructor gets a reference to the range that it's iterating over, right? The reason it needs that range object is so that it knows what the start and stop values are. So inside my class, inside my range iterator class, right, I have a reference to the range that we're iterating over. Right? Remember what the iterator needs to do. It needs to count from the start of the range up to the end of the range. Right? So it needs the current value that we're looking at in the range. So that's going to be val. Right? And now you go ahead and implement the class. Right? So there's our constructor that takes an arrange object. Right? We're simply going to set this range equal to R. Right? Now, the starting value, this is where we run into a problem. Right? So val is the current value that the iterator is looking at in the range R. Right? So what's the current value that we're looking at? Well, we're looking at the start value in the range. So I want to write this range.start, right? But if you go and look in the range class, right, start's private, right? And that's a problem, right? I'm inside the range iter class, right? I can't see the private parts of range, right? So that's not going to work. Okay? So you ask yourself, well, okay, so how do I solve this problem, right? And one of the answers is, well, does range have a method that returns the start value? Right? A non-private method that returns the start value. So you go and look in the range class and you look for a method that returns the start value and you don't find one. You say, well, no, there is no method in the range class that provides the start value. Right? And so now the only way to go forward is to either provide a method, is to change the range class so that it has a method that returns the starting value, right? Or it's to make that field accessible to the range iterator class. So I'm going to do the easy thing, and I'm going to make the field accessible to the range iter class. Right? And the way you do that is to strike private from here. Right? So when I do that, right, I've now made the start field package private. Right? Package private means that field is accessible to any class in the same package as range. Right? And range iter, turns out, is in the same package as the range class. Right? So now, Java's perfectly happy, or the compiler's perfectly happy with that. You're going to have the same problem with stop, right? So stop is also private in range. So I don't have access to it by name in range iter. There's no method that returns the stop value, right? So I'm going to do the expedient thing here and make the access modifier on stop be package private, right? And so now range iter has access to the range's stop value. Okay, so there's our constructor. We're implementing that interface there, right? Iterator says you must provide a hasNext method, right? Okay, so what does hasNext do? HasNext returns true if the current value, right, is not the end value of the range, right? Or is less than the end value of the range. So that's easy to implement. Right? Look at the current value and compare it to the stopping value of the range. Right? So if this value is less than this range.stop, right, we know that there's still values in the range to look at, so we'll return true. Right? As soon as the value is equal to range.stop, we know that we've finished looking at every value in the range, and so now hasNext will return false. So what does next do? So next has to do, in principle, it needs to do three things. Right? The two things that we know it has to do is it has to return the current value of the current value that the iterator is currently visiting, and then it has to advance the iterator to the next value. Right? So the current value that the iterator is currently looking at is stored in this .val. Right? You have to remember you have to advance this val by 1. Right? So that's why I'm storing it in a temporary variable result here. Right? It's because I need to change this val. I have to increment it by 1 to advance the iterator to the next value. Right? Then I can return the remembered value result. It turns out next has to do a third thing. Right? And so the specification for the next method says next must throw an exception if the iterator is already at the end of the sequence. So in other words, if hasNext returns false, next must throw an exception. And the exception it must throw is that one right there. Right? So if you're ever using an iterator and you end up getting a no such element exception, it means the iterator has finished looking at every element in the sequence, and you've asked it for more elements to look at. Right? And that's it. Right? So you're done your range iterator class. Right? You have to provide a next method. You have to provide a hasNext method. Right? In our current implementation, we need the range, or the minimum and maximum value of the range that we're iterating over. Okay, so does this thing work? I guess that is the million-dollar question. I'm going to comment out the last two loops, because that's going to be our second implementation of this class. Right, so that's using our current implementation. Let's run that. And we get the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this thing really does iterate over the sequence 0 through 9. Right? If you want to write a for each loop, we can try the next one. Right? So if I've done everything correctly, the next loop should also work. Right? So the next loop uses a for each loop over a range object. Right? Our compiler performs a bunch of magic, right? Translates this into something that looks like this. Right? So this should print out the sequence 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as well. And it does, right? So we get 0 through 9 printed out twice, right? Once up here, a second time here. Okay. Any questions so far? Right? All we're doing is we're making a class that can count from one start value up to a stop value. All right, so what did we have to do when we implemented this class? Right? Well, I needed a reference to the range. That makes sense, right? I need to know what is the minimum and maximum values that I'm counting over. Right? Now, if I use a reference to the range, I need to be able to get access to the starting and stopping value of the range. Right? And so in our solution here, I elected to go into the range class and change its start and stop fields so that so that we could see them inside range iterator. There is another solution that you can take. Okay, so there's our range class. Right? Inside range class, there has to be an iterator method, right? Because our range class implements iterable, right? So iterable says there must be an iterator method that returns an iterator. So there it is, right? So I need to be able to make an iterator that can iterate over a range. So I need some class that represents such an iterator. Right? The class I just showed you was called rangeIter. Right? I'm now going to show you a second class called rangeIterator. Right? And we're going to implement this one in a different way. Right? So here, the rangeIterator class lives inside the range class itself. Back here, right, rangeIter was its own top-level class, right? It was its own separate class, right? Lives outside the range class. Right? In this implementation here, right, I'm going to make a private class inside of another class, right? And so we haven't seen this yet in the course, right? So in Java, you can put a class inside of another class. Right? So when you do that, it's called a nested class, right? Just like you would have a nested loop, right? A loop inside a loop, a loop inside of a loop. So here, rangeIterator is a nested class. Java has a very particular terminology for this type of class, right? This class happens to be an inner class, right? And so I'll explain exactly what an inner class is in just a moment. Okay, so this class is also private. So remember what private means in the Java language. It means nothing outside of the class, so nothing outside of rangeIterator, can actually see the rangeIterator class, right? Except, in this case, right, rangeIterator is defined inside of range, so range can also see the rangeIterator class, right? So there's only two classes that can see rangeIterator, right? It's the rangeIterator class itself, and it's the class that it's defined in, right? So range can see it, which means range can make a rangeIterator object, right? So that makes that line of code there legal. So that's what the private here means, right? Now you might ask yourself, right? Why is this class private, right? And so the answer to that question is because if you want to iterate over a range, right, you need a range object already, right? Makes sense, right? That's how it works, right? If you're going to iterate over a sequence of values, you need the sequence of values. So you need the range object anyway, right? If you have the range object anyway, right, you might as well make the class range iterator private because the only class that needs to make a range iterator object is the range itself. Right? You can't iterate over a range without the range, right? So you might as well make the range class create the range iterator object for you. Right? In other words, right, there is no purpose for the range iterator class except to iterate over a range. Right? The only reason this class exists, right, is so that range can provide its iterator method. Right? No one else ever needs to make a range iterator object directly. Right? If you ever need a range iterator object, you just ask the range for its iterator. Right? So in this case, it does make sense to hide the existence of the range iterator class. Right? No one else needs to make one, so no one else even needs to know it exists. Right? So that's why we're making it private in this case. Right? Making it a nested class, or an inner class in this case, addresses some of the other problems we had to deal with when we created our previous class. Okay, so this is the first time we've seen a nested class, right? So what is a nested class in Java? Well, it's just a class that's defined inside of another class, and that's it. Right? When do you make a nested class? So normally, the only time you make a nested class, right, is when you are creating a class whose sole purpose is to serve the class that it's defined in. Right? So in other words, range iterator only exists because range wants to implement the iterator interface. It's its only purpose. Right? If you choose to implement a nested class and you realize at some point, hey, someone else might want to use this class, right? That's when you should make it its own top-level class. Right? So here, our first attempt at the iterator class was its own top-level class. Right? After implementing the class, we've realized this class doesn't need to exist except to serve range. Right? So in other words, no one's going to find this class useful. No one can make a range iterator object without a range. Right? So this class is not really useful on its own. Right? It needs the range class in order to exist. If that was not the case, right? So in other words, if you could make a range iterator object without a range, then it makes sense to make range iterator its own separate class. Right? But that's not the case. So here it makes sense to make a nested class. Iterators are almost always defined as nested classes, right? Because you can't have an iterator without the enclosing class. Right? There's a class called listIterator that we don't know about, right? It's defined inside the list class, right? You can't have a listIterator without a list to iterate over. Right? Similarly, you can't have a range iterator without a range to iterate over. Right? And so it makes sense to put these classes inside of the sequences that they're iterating over. All right, back here. So that class there looks like a regular Java class, right? It's got an access modifier, it's got the word class, it's got a name. So it looks like a regular class inside of another class. When that's the case, it's called an inner class. Right. Okay, so objects of an inner class type, they always have a reference to the enclosing class object. What the heck does that mean? Right? So range iterator is an inner class of range. Right? That means every range iterator object has a reference to a range object. Right? Right? So every one of these objects, right, has a reference to its enclosing range. Right? Remember our previous implementation, right? What did we need to do when we created a range iterator object? We needed to provide it a reference to a range to iterate over. Right? That's what that field is right there. Right? That's the range that we're iterating over. Right? So by making range iterator a nested class, right, I no longer need a field that looks like that. Right? The language says it already gets one. Right? So that solves one of the problems that we had in the previous attempt. Right? So now every range iterator object gets an automatic reference to its range object. What else can an inner class do? Right? So inner class objects are allowed to access the fields of the enclosing class object. Right? And so that means every range iterator gets access to the fields of range, even if the fields of range are private. Right? So every range iterator object can access the fields of its enclosing range object, regardless of the access modifier that range has put on those fields. Okay. So how do we go about implementing this class? Well, now you implement the class exactly the same way we implemented the previous range iter class. Right? So rather than look at the slides, let's just go look at the code. Right? So there's our inner class. Right? It also implements the iterator interface. Right? What does every range iterator need? Well, it needs to know what is the current value. Right? So what is the value that's supposed to be returned by next? So just like our previous implementation, we need to keep track of the current value. We don't need to keep track of the range because we automatically get a reference to that object anyway. Right? So what does our constructor have to do? Right? Our constructor needs to set value, right? And it needs to set value to the starting value of the range. So this is one of the parts of implementing an inner class that looks kind of gross. Right? So every range iterator object gets a reference to its enclosing range. Right? The name of the reference is very weird. Right? Instead of, so remember what this is inside of a constructor. Right? This is a reference to the range iterator object that is currently being constructed. Right? If you want to get to the range object that belongs to this iterator, that the iterator belongs to, you write the name of the class followed by this. Right? So range.this is a reference to the range that this iterator belongs to. Right? Syntax is weird, it's gross, right? But that's just the way it is in the language. Right? So if you want the starting value of the range that this iterator belongs to, it's range.this.start. Right? Where start is I can make this private now. So I can put this back to private, I guess is the better way to put it. I have to change, I'm going to change that in just a second. Right? So notice here, Eclipse is perfectly happy with that line of code. There's no error there. Right? So once again, range.this is a reference to the range object that this iterator belongs to. Range.this.stop is range.this is a reference to the range object that this iterator belongs to. Right? Range.this.stop is the stopping value of the range that this iterator belongs to. Right? So hasNext looks exactly like hasNext from our other class, right? Except now instead of writing this.range.stop, we write range.this.stop, right? We write that instead, right? We have direct access to the field anyway. hasNext is exactly the same as hasNext from before, right? Remember, what is the current value that the iterator is looking at? Right? Update the current value, return the previous current value. Right? If there are no more elements to look at, throw an exception. Right? Right? So implementing the inner class is really no different than implementing the top level class, except for a syntactic difference here. Right? When you want to reference the enclosing range object, right, you write big R range.this. Right? You no longer need an explicit field to refer to the range object that this iterator belongs to. You get it automatically. Right? You can access the private stuff inside of range from the inner class here. From the inner class here. Okay, the last thing I need to do is I need to update our iterator method. Right, so now I can just return new range iterator, like that. Right, so now that I put everything back to private, our range iter class is busted again, so I'm going to comment this out. Because this was using the old, actually that one should still work. And put these two back. that. There we go, like that. Okay, so now we're using our new nested class as the iterator, and it still works. Right, so we still get the range output twice. Right, once there for the for each loop, and once there using the explicit iterator. That's fine. Okay. And so there is the implementation of an iterator class, right? This one for over a sequence of integer values, right? Using both a top-level class and using a nested inner class in this case. Right? Again, notice the weird syntax when you're using the nested inner class. Okay, any questions about what just happened? There is actually a lot going on there, right? So at some point you might want to go back and review what just happened in that discussion. All right, so if there are no more questions, I'm going to now move on. So we've implemented several interfaces now in the course, right? So we've done comparable, we've done iterable, we've done iterator, right? What if you wanted to make your own interface? And so it turns out it's very easy to make your own interface. Right, so if you want to make your own interface, you simply declare the interface just like you would declare a class, except you change the word class to interface, and that's more or less it. Right? Some of the things you need to know when you implement an interface is that, when you create an interface, is that everything in the interface is public, right? Whether you mark it public or not. Right? So if you create your interface and you don't mark everything as being public, the compiler automatically makes everything public, right? If you list everything as being public, that's fine. If you try to make something private or protected, the compiler will complain, right? So it will not let your, it considers that to be an error. Okay, so let's make a very simple interface that's not particularly useful, but illustrates the process. So I'd like to make a printable interface. So the printable interface is simply an interface for objects that you can print to standard output, right? So when we made the point2 class, we overrode toString, right? To print a string, to print a point object, you can just write system.out.println point, right? And that prints the string. So I want to be able to do this in general, so for all objects, right? So one way you can do this, this is not a good way to do it in Java, but one way you can do this is you can make everything implement what's called a printable interface, right? So we need to, so what methods should this interface have, right? So it should probably have a method called print, right? And so there it is. Right? So our method print simply prints the object to standard output, right? And that's it. So there's our first extremely simple interface. Okay. So now suppose, how do you use the interface, right? So now you say, well, I'd like to be able to print points, right? I can print a point by implementing the printable interface. Right? So go into your point2 class, right? Do a little bit of surgery, and say it now implements the printable interface, right? So notice here, our point2 class, it previously implemented comparable, right? We're now implementing a second interface called printable. When a class decides to, or when a class implements more than one interface, you simply separate the interface names with a comma. Right? So in Java, a class can implement as many interfaces as you like, right? There is no built-in upper limit. Our point2 class is now going to implement two interfaces. Right? You don't change anything in the class, right? You don't have to go in and change the constructors or any of the other methods, right? All you have to do is provide whatever method printable says you must provide. Printable says you must provide a print method, right? That looks like public void print, right? You can't change this, right? When you implement the interface, right? So I'm going to provide the method public void print, right? You can put in the @override tag if you like, right? If you put it in, the compiler will check, is there a method public void print in the interface printable? If the answer is yes, everything's fine. Right? If the answer is no, so for example, suppose you spelt print wrong, right? The compiler will tell you, hey, you're not implementing the correct method in printable. Right? How do you implement print? Well, you just call system.out.println and then the point2 string. Right? So here I'm using this toString. You could just write toString, right? And whatever point you have, we'll call its toString method, right? So now instead of writing system.out.println p, you can just write p.print, right? Which admittedly doesn't really buy you a whole lot, right? You can print anything in Java just by writing system.out.println followed by the thing, right? So that's why I say this interface is not particularly useful, right? And you probably shouldn't implement it this way, right? Printing stuff out in Java and Python is straightforward, right? There's no need to make an interface that also prints something out. But there's I guess this baby's first interface, right? Okay, I guess I'll stop there. And so the rest of the course is we're going to start implementing data structures. And so when you implement a data structure, it turns out that there's often more than one way to implement the data structure, right? And each of the different ways that you might choose to implement the data structure, they all have certain advantages and disadvantages, right? Typically, the advantages and disadvantages are in terms of their computational complexity, right? And so the rest of the course is we're going to implement a few different data structures, right? We're going to use interfaces to define what the data structures do, and we're going to look at different ways to implement the data structures and see what the trade-offs and advantages are. All right, so that's it for today. I guess I'll see you again on Thursday. No, sorry, yeah, Thursday.